Hello everyone and welcome back. I have a bit of a different video for you today. We're not going to be in ADIAT itself this time. We're going to be talking about one of the aspects of drone operations, specifically talking about the optimal gimbal angle for capturing images. And this applies certainly to images that are going to be used for image analysis in ADIAT, as well as just generally speaking for SAR operations. This is actually a bit of a callback to our very first video, the overview video, where we talked a little bit about computer vision as well as best practices for drone operations for use with ADIAT. And in that section, we called out the best gimbal angle to use was -90 degrees because that gives you the best reference point where the drone is centered in the middle of the image, and that corresponds to the GPS coordinates that are stored in the image metadata. After that, we got some great feedback from users all over the world, talking about some alternative perspectives on better drone angles to use for search and rescue operations. Specifically, we got an email from Ron Samansma, who's a member of SAR Netherlands, and he pointed us to a paper done by Superintendent Andreas Ostad Nielsen from the Norwegian Police Unmanned Air Support Unit. And I'll put a link to that paper in the description of this video, where they did a lot of great research and came to the conclusion, hey, there's certainly benefits to using angles other than straight down. And we'll talk about some of those. We'll kind of experiment with some of what they call out in their paper and take a look at a couple of other aspects as well. So with that, let's jump on into it. All right, starting with a little bit of level setting, what we're talking about today is the optimal gimbal angle, which is really the angle of the camera when you are taking pictures from the drone. So with most drones, 0 degrees means it's pointing straight ahead of the drone in the direction of travel. -90 degrees means it's pointing straight down. And of course, you can go anywhere in between those two, usually using a wheel on the side of the controller for most of the drones, or certainly the DJI controllers. And what you're doing is you're adjusting the tilt of the camera, which adjusts the field of view for the images being captured. And this certainly has impacts to the images that are captured for use with ADIA in image analysis, as well as all sorts of other things you might be trying to do with those images, like creating orthomosaics or modeling or anything like that. So let's take a look at some of the claims for why one particular angle or extreme is more beneficial than another. And really it comes down into two categories here. We have the -90 degrees, which is also known as nadir, and we have anything else, which is known as oblique. So pointing straight down, nadir. Anything between straight down and pointing straight ahead is an oblique angle. Claims on the -90 degree side of things, as we said in the beginning, it's easier to correlate image GPS coordinates to objects of interest. So the GPS coordinates that are stored in the image correspond to where the drone was when the image was taken. Well, at -90 degrees, the drone is dead center in the image, so everything kind of has that reference point as the starting point for determining its actual ground location. Other advantage to -90 degrees, or claimed advantage to -90 degrees, is it avoids distortion for creating orthomosaics and greatly simplifies GSD calculations. And we will, of course, dive into each of these in a moment here. On the oblique side, the claims for why it is beneficial: it provides better visibility under a canopy of trees, and it makes subjects who are standing up appear bigger in the image. So that first claim on the left side, or the -90 degree side, was that it's beneficial because in images taken at -90 degrees, the center of the image corresponds to the GPS coordinates that are stored in the image, and therefore it is easier to identify where a subject is actually located based on an image because we have that information. What does that actually look like in practice? So we have this image here, which was taken at -90 degrees or nadir, and the center of the image, which is this red dot, also corresponds to the drone's location. Given that information and given that we're straight down, we can tell if something is up here, roughly how far away it is from that nadir point and from those GPS coordinates. Conversely, if we have an image like this, which was taken at negative 75 degrees, an oblique angle, the center of the image is now here, but the drone was still down here when the image was taken, and that's the GPS location that will be stored in that image. So now, instead of knowing, hey, the center of the image is exactly where those GPS coordinates are listed as in the drone or in the image, we're off by 105 feet. So is it true? Yes. Is it a deal breaker? Probably not. So if we look at the actual math here, so if we're at 400 feet, obviously GPS location pointing straight down is going to be right where the drone is. If we go to a negative 75 degree gimbal angle, so 15 degrees from nadir, I'll save you the high school geometry lesson, but we're up 400 feet. We're off by what should be 107 feet. And the other image we saw is about 105 feet ground truth, so it counts for image distortion, camera distortion, those sorts of things. Likewise, if we go out to negative 60 degrees, then the center of the image is going to be 230 feet roughly from where the drone actually is. Does it make some of the numbers and calculations a little more cumbersome? Sure. Is it a deal breaker? Probably not. I think if you get used to it and you understand, and of course the information is captured in the image about what the gimbal angle was, the relative altitude, all those things, you can fairly quickly calculate the actual location of the center of the image. So yes, it is absolutely true that life is easier if the GPS coordinates of the image correspond to the center of the image, but with a little bit of math, you can still get to the same point pretty quickly. Moving on to the second claimed benefit on the negative 90 degree or nadir side is the claimed benefits for calculating ground sampling distance as well as generating orthomosaics. And really what this comes down to is the benefits as it pertains to the field of view in a image taken at nadir versus an oblique angle. With an image taken straight down, you see the field of view is pretty well rectangular, and because of that, the ground sampling distance calculations are fairly straightforward as long as you have the camera and flight characteristics available to you. As we move to an oblique angle, the field of view becomes more trapezoidal because the near edge of the image is that it is much closer to the camera than the far edge, and because of that, the ground sampling distance at the top of the image is larger than the ground sampling distance at the bottom of the image. And that makes our GSD calculations much, much more complicated. Going back out to our football field, we can see what this looks like in action. So if we take this football field and we overlay a trapezoid on it, at first it's going to appear reverse of what we just said, because the top of the trapezoid here is narrower than the bottom. Well, that's because it's kind of the inverse. What's shown here in the football field is saying that, hey, the football field represents a smaller portion of the overall field of view at the top than at the bottom. So yeah, it seems reversed at first, but when we look at the math, it's actually lining up with what we predicted there in the math. So if we take a look at the 10-yard line here, a American football field is 4,877 centimeters wide. That is represented by 2,214 pixels. That makes our GSD 2.20 centimeters per pixel at the 10-yard line here. If we go to the opposing 20-yard line, it's still 4,877 centimeters wide on the ground, but it is now represented by 1,487 pixels. So our GSD has gone up to 3.28 centimeters per pixel. So over the course of the 70 yards here, our GSD has increased by almost a full centimeter. So why does that matter to us? Hopefully we're not manually calculating ground sampling distances in a lot of images, but it's important to understand the principles behind this and the potential impacts it might have on software we use to do things like generate orthomosaics for us or 3D models or anything like that, because they have to deal with that complexity. They have to deal with the GSD calculations being different from one end of an oblique image to the other. And as an exercise, I wanted to see what the impact of this was in creating an orthomosaic using a combination of DroneLink and Pix4D React. So I took two of our drones, a DJI Air 2S and a Mavic 3T, and flew mapping missions using DroneLink at 100 feet AGL and 300 feet AGL with the gimbal set at negative 90 degrees, negative 75 degrees, negative 60 degrees, and negative 45 degrees. I also set three cones out in the field where I was doing this mapping two of them were set basically parallel to the direction of travel of the drone. Two of them were set perpendicular to the direction of travel of the drone, just to see if there's any distortion in the calculations of distance between objects as it generated the orthomosaics. So as I said, flew this autonomously through DroneLink, then took all those images and built out orthomosaics of them using Pix4D React. And this was the results of that exercise. As you see, we have our two orthomosaics here. These are both from the Mavic 3T, flown at 300 feet. The one on the left here was at negative 90 degrees, so nadir, and this one is at negative 45 degrees. As you see, there is significant distortion on the one on the right, the negative 45 degree one, especially as we get outside of our target area. So the actual area we asked to map was right about here, kind of this creek and field area. All this is outside that area, but you can still see there's a lot of distortion there. We can also see that trapezoidal effect we were talking about in the previous slides. Next, we'll see there's actually some significant alignment issues. So this is from the negative 45 degree angle orthomosaic. The images were not aligned correctly by the software as it generated the orthomosaic, and even as low as negative 75 degrees, so only 15 degrees off of nadir, there were some issues with the alignment. We see kind of this artifacting thing. This was one of those cones I put out there where this is the actual cone and there's kind of a shadow or a ghost cone right behind it where it didn't quite stack and stitch the images correctly. So something to definitely be aware of. Good news is there was minimal impact to the accuracy of the ground measurements when everything did align. So good news on that front, but definitely, as we were concerned about, significant issues with using non-nadir images for generating orthomosaics, at least in this setup with DroneLink used to create the images or capture the images, and Pix4D used to stitch them together for the orthomosaic. I know there's systems out there, Smart Oblique, I think is what DJI calls it, where it intentionally takes multiple images and mapping missions to create 3D modeling and those sorts of things. That works well when it's combined with DJI's Terra software, because obviously same company, they're designed to work together. Overall, though, there's some problems here, especially as we get into these more extreme angles. So if you're interested in generating orthomosaics from the images you capture in your flights, something to definitely be aware of. That takes us over to the right side of our comparison, and this is the benefits of the images from non-nadir angles. The first one being, hey, if we're always taking images straight down and a subject is underneath a tree canopy, we're never going to be able to see them because they're going to be obscured by that canopy. And pretty straightforward to visualize here. If we have the drone directly above the subject or directly above a tree and the subject under the canopy of the tree at negative 90 degrees, we're not going to see them. We're going to be blocked by the canopy. Same setup, but if we move out a little bit and set the gimbal angle to negative 60, well, now we're going to be able to shoot kind of under that tree canopy and be able to find that subject. Now, there are a few additional points we need to consider here for this case. So starting with impact depends on the camera's field of view. Let's go back to our previous slide here. So as we see, the effectiveness of this kind of depends on the camera's ability to sneak under the tree here, and that's going to depend on how wide the field of view is, especially in the vertical direction. If you have a really narrow field of view, you might not actually be able to see the person even if you are at an oblique angle. So that's our first point. Second point, this is less effective around trees with a wide, low canopy. So where we are in central Texas, a lot of our trees have a pretty low canopy. We're in a very arid climate and it's pretty hot down here. So the trees tend to go out more than they go up to shade their root system and all those things to protect them. So less effective where we are, but if you're in an area that has taller trees, definitely this can be beneficial to you. Next, shadows from the trees can impact the effectiveness of color anomaly detection algorithms. So going back to our ADAT use cases here, if you're looking for a subject and you're saying, hey, this person was wearing a red shirt, a blue shirt, whatever, that shade of red or blue is going to look very different in a subject that's in the shade of a tree versus out in an open field. So just something to be considered depending on how the color range is set and those sorts of things. It may not get picked up as efficiently because it's a very different color than it would be if the person was out in a field. Next, ground distance to subject may make detection more difficult. So because we're going to be further away from the subject horizontally, they're just going to appear smaller in the image. So again, just something to consider that you're going to be a little further away from the subject, so you may have to take an extra look to see them under the tree. Finally, just by the nature of, the nature of trees, you may require multiple passes from different directions to see a subject under a tree. So the canopy is most likely not symmetrical, and depending on what side of the tree the person is on, the subject is on, you may not see them if you're only going one direction back and forth. So rather than kind of a back and forth pattern, you may have to do a grid or make an intentional effort to encircle individual trees to see someone under a tree. So the other claimed benefit for using non-nadir angles for capturing images is the impact to the size of a subject in the captured image. So if you think about it, if you're flying over a subject and you're pointing straight down nadir negative 90 degrees and you're directly over them, that person is going to occupy a fairly small portion of the resulting image because it is truly just the footprint that they take up on the ground. Whereas if we back off a little bit and we're, 100 feet away from the person and have the camera angled slightly towards them, you're getting more of that diagonal view of the person, and they're going to take up a lot more of the pixels in the resulting image. So to test this theory, we went ahead and set up a 7-foot tall board at the end of a field, and then took our two drones, the Air 2S and the 3T again, and flew mapping missions with DroneLink at 100, 200, 300, and 400 feet AGL with the gimbal angles at negative 90, 75, 60, and 45 degrees. Again, took images of the board from everywhere from right on top of it to 200 feet away, and then took all those images into photo editing software and measured the diagonal distance across the face of the board just to give us a standard measurement for how visible is that board in those images. So here are the results of that experiment. We did see a very strong correlation between our gimbal angle and the perceived size of the subject in the images. So the closer we were to horizontal or the more oblique angle we were at, the more visible the subject would be in those images as we predicted at negative 45 degrees. So our closest to horizontal that we went, on the 3T, the average diagonal length of the board was 118 pixels, whereas at nadir, negative 90 degrees, it was less than 40 pixels. So definitely a strong benefit to being further away from nadir, and the benefits of the subject taking up more of the picture, and especially if they are standing up. One odd thing to note, though, due to some of the impacts of distortion, at a single altitude and ground distance, the board size doesn't actually show that same linear relationship. So, for example, when we were at 300 feet AGL and 100 feet from the board on the ground, we had our 4 angles, or images from our 4 different angles, and you see definitely doesn't show that same relationship that we see with the overall measurements. So just something interesting to note, that we see the overall trend, but at any particular height and distance, it didn't necessarily line up the exact same. All right, so to recap, we had our 4 claims here. First one for wide nadir is better, is it's easier to correlate image GPS coordinates to objects of interest. I'm going to give that half credit. Yes, technically it is easier because, again, the GPS coordinates align to the center of the image, but the math to figure out where something is in an image, in an oblique image, isn't all that complicated, and shouldn't really be a deal breaker for why you need to use nadir images for what we're doing. Second one on why nadir images are better, it avoids distortion for orthomosaics and simplifies GSD calculations. 100% give it full credit on that one. Yes, the nadir images were much better for generating orthomosaics out of DroneLink using Pix4D. Over on the other side here, why are oblique angles better? Well, first, they provide better visibility under the canopy of trees. I gave that about 75% credit because there are those things, and probably biased just based on the trees where we are and why they are not all that easy to see under. But yes, in a lot of scenarios, absolutely, being at that oblique angle does give you that benefit of being able to see under the tree canopy. And lastly, over here on the right, make subjects who are standing up bigger in an image. 100%, we just saw that in that last example. The more oblique the angle is, the more visible the subject will be in the image. So where does that leave us? What are our final recommendations? And it's going to vary a little bit depending on what your use case is. Starting with, if we're looking at mapping missions, unless you're using specialized software that takes advantage of oblique angled images for 3D modeling, go ahead and just leave the gimbal angle set at -90 degrees and fly at constant altitude, usually somewhere between 150 feet and 300 feet AGL. Really, that's going to come down to the camera that you're using and environment that you're in. And if at all possible, go ahead and fly using autonomous mapping software just to get that consistency that is required for some of those highly precise stitching algorithms to work correctly. On the other end of the spectrum, if you're doing ad hoc flying, looking for a subject, following trails, paths, waterways, that sort of thing, go ahead and set the gimbal angle somewhere between -45 to -60 degrees to get the benefit of what we just looked at with the subject size. Variable altitude, you're going to be going up and down depending on the terrain and all those things, and make adjustments so that you can see under the tree canopy. And finally, our recommendation for when you're flying search patterns, or if you only have one shot at this and kind of need that Goldilocks setting, a recommendation would be set that gimbal angle at -75 degrees. That way we get some of the benefits of flying with the camera at an oblique angle with regard to subject size and being able to see under the tree canopy, while still maintaining the field of view and avoiding some of the trapezoidal effects and those things that could negatively impact our ability to generate orthomosaics and things like that. Fly at a constant altitude. Recommendation here is 200 feet. I will note both gimbal angle and altitude settings. A lot of this is going to depend on your camera and your equipment. The field of view is going to play into this. The sensor size is going to play into it as it affects ground sampling distance and those things. So these are just a general guideline, but our best recommendation for a generic set of recommendations here. And lastly, fly if possible using some sort of autonomous software, be it drone deploy, drone link, drone, whatever, whatever you use, just to avoid some of those inconsistencies that come with flying by hand. That is all we had for you today. Thank you very much for taking the time to watch our video. If you have any comments or suggestions, or your experiences have led you to believe that there are other angles that are more beneficial for how you fly, please, by all means, feel free to comment below or reach out to us, and we'd love to discuss it further.